Let's talk about a few important topics. There are several benefits of large language models, among which I can mention natural language understanding and generation. This is one of the main ones. LLMs enable machines to understand and generate human like text, which enhances communication between humans and machines. Also, the automation of language tasks. LLMs automate tasks like content creation, customer support, language translation, and code generation. This is something that you see every day. People telling you how to use LLMs to increase efficiency and productivity. Also, accessibility. LLMs can assist individuals with disabilities by providing text to speech and speech to text functionalities. And the list goes on and on. However, I'll leave it here as I will be telling you about other benefits as we move into the demos. Now, let's talk about the multiple challenges that come with all this. For example, bias and fairness. LLMs can inherit biases present in the training data, leading to biased or unfair outputs that perpetuate social stereotypes, as well as misinformation. LLMs have a great ability to generate text that can inadvertently lead to the spread of false information, impacting public discourse. And ethical dilemmas. LLMs raise ethical questions about the authenticity of generated content, ownership of text, and the potential for misuse. Despite and because of all this, large language models find applications across diverse domains. Maybe one or more of these is exactly what you're working on. For example, content generation. LLMs can generate articles, stories, poems, and other forms of creative content. Then chatbots and virtual assistants. LLMs power intelligent chatbots and virtual assistants that engage in natural conversations with users. Then language translation. They facilitate accurate and rapid translation between languages. Also, code generation. They assist developers by generating code snippets based on natural language descriptions, as well as sentiment analysis. LLMs analyze text sentiment, helping businesses understand customer opinions. However, despite their power, LLMs have limitations. For example, lack of causality. The bidirectional nature of attention means that the model doesn't inherently understand causality, which can lead to generating implausible sequences. Then, scale dependency. LLM's performance often improves with larger sizes, but this comes at the cost of increased computational requirements. Interpretable representations. While representations are learned, the inner workings of the model are not inherently interpretable. Lack of true understanding. LLMs lack true comprehension of text and rely on patterns learned from data. Incorrect information. They might generate plausible sounding but incorrect information. Basically, something that sounds right, but it's not. And here's a very important one: dependency on data. LLM's performance depends on the quality and diversity of the training data. The old saying, garbage in, garbage out, is quite right here. Which takes me to what I think is one of the most critical points: responsible AI usage. The responsible usage of large language models is of paramount importance to ensure the ethical and equitable deployment of these powerful language generation systems. Integrating responsible practices safeguards against biases, misinformation, and misuse while promoting transparency and user trust. So, what can we do? Well, here are a few things that we can do for bias mitigation and transparency. First, bias identification and removal. Responsible AI usage involves identifying and addressing biases present in training data. Thorough evaluation and correction of biased language representations are essential to prevent perpetuating social, gender, racial, or cultural biases. Next up, algorithmic auditing. Auditing LLMs for potential biases demands continuous monitoring and assessment. This process requires collaboration with diverse experts to review outputs and refine the models to minimize unintended biases. Then, transparency in training data. Disclosing the sources and characteristics of training data ensures transparency, allowing users to understand the context and potential biases that might influence AI generated content. And let's not forget the ethical considerations. First, authenticity and attribution. The ethical landscape involves distinguishing AI generated content from human authored material. Incorporating watermarks or markers within AI generated content can help differentiate between sources and maintain authenticity. Then, ownership and copyright. The question of ownership and copyright for AI generated content raises complex ethical issues. Responsible usage entails determining legal ownership, attributing authorship correctly, and ensuring respect for intellectual property rights. And of course, we need to ensure user awareness and education. For this, we have an informed interaction. Responsible AI usage requires educating users about AI capabilities and limitations. Clear communication about the nature of AI generated content empowers users to differentiate between human and machine inputs, as well as critical engagement. Educating users about AI's potential fallibility encourages critical thinking. Users should approach AI outputs with a healthy dose of skepticism. They should verify information when necessary. Despite of all what I said, I think there's a great future in store as long as we do all this in a collaborative effort with a global ethics framework. Building responsible AI ecosystem requires collaboration among AI developers, policymakers, researchers, and users. Establishing global ethics frameworks ensures consistent guidelines for AI deployment and usage, as well as stakeholder engagement. Engaging diverse stakeholders, including communities affected by AI outputs, helps incorporate multiple perspectives and prevent unintended negative consequences.